Hello students, and welcome to week 13 of our course. I hope everyone is staying safe and doing well and also keeping up with their courses and course material. This week we are going to be finally covering regression, which is the topic that I had discussed at the beginning of class and mentioned that it was one of the most challenging but also one of the most rewarding topics that we will be covering this semester. Before I get to the handout, I want to really quick go over the remainder of the course schedule. I want to point out that I just sent out another email to the class saying that I messed up. There was a typo on one of my previous emails to you. I had said that your assignment 4 was due Monday the 17th, but really Monday is the 13th. 17th is the Friday. So because of that confusion, I am going to be extending the deadline to Friday the 14th. You have until right before midnight to turn in that assignment. For those of you who already turned yours in, very good. You don't have to worry about it, and thank you for getting your work in on time. Also, this Friday, you have your 8th pop quiz, so be sure to log into Blackboard and access that before midnight on that day. All right. Okay, so this week, we are going to be learning linear regression, okay? Linear regression can take form in two ways, simple and multiple, and we'll discuss how to distinguish between those two. When we are talking about regression, it is a very simple extension of correlation. Okay, if you remember from the last lesson, correlation looks at the relationship between two continuous variables, and the Pearson R coefficient tells us the strength of the relationship between those two variables. If it's a negative coefficient, an increase in one variable is associated with a decrease in another variable, right? And if it's a positive coefficient, an increase in one variable is associated with an increase in the other variable. Okay, so linear regression kind of works the same way. Linear regression is predicting an outcome variable, okay? An outcome variable is also called the independent variable. I'm sorry, the dependent variable. So what we are predicting is the dependent variable. You will hear me refer to this as the outcome variable, okay? So always remember that the dependent variable is what we are trying to see its effects as being predicted by other variables, okay? Now, the variables that we are using to predict the dependent variable are what we call the independent variables. I've often referred to these as predictor variables, okay? So one example of linear regression is, for instance, trying to understand whether household income is related to a child's performance in their school, or whether household income is related to one's educational attainment, okay? Now, one of the questions commonly asked is, well, what is the difference between simple regression and multiple regression? It's very simple, okay? When you have one independent variable predicting the outcome variable, you are using simple linear regression, okay? So again, simple linear regression is using one independent variable to predict one outcome variable, okay? Now, when you are using more than one independent variable to look at an outcome variable, that's what we call multiple linear regression, okay? Multiple linear regression uses more than one independent variable. Simple linear regression uses one independent variable. Now, the nature of regression is designed to tell us several things, okay? One of the things that it helps us to identify is the strength of the independent variable and its influence on the outcome variable. So how strongly your predictor variables influence the outcome, okay? It also tells us the magnitude of their effects. So not just the strength of their effects, but how large their effects are, okay? When we are looking at magnitude, you can think of it as how much the outcome variable is changed based on changes in your independent variable. All right. One of the most important things to remember about linear regression, whether it's simple or multiple, is that your outcome variable, your dependent variable, always should be continuous. Okay, and remember, continuous is anything that is interval or ratio. So some examples are time, which is measured in hours. If you're using a measure of intelligence that is measured using IQ score, that's a continuous measure. Weight measured in pounds is also continuous. Some of the more classic continuous examples that we used in class were age, educational attainment, and income in actual dollars. Okay, so again, when you are using linear regression, your dependent variable needs to be continuous. No ifs, ands, or buts. All right. Now, as far as your independent variables, they can be any level of measurement, okay? They can be categorical, they can be ordinal, they can be continuous, it doesn't matter. But remember, if you have an independent variable that is categorical, okay, for instance, the variables for marital status or race, okay? If your variable is in this level of measurement, remember, you need to first create dummy variables for each of the categories. Some of the examples that we used in class were creating dummy variables for marital status. Remember, marital status had multiple categories, and we created dummies for each of those categories, right? Remember, we created binary variables for each category. So separated, divorced, widowed, a 1 equals any one of those categories, a 0 is anyone else. Okay, never married, 1 equals never married, 0 equals everyone else. We created dummies for race also, white, black, and other. Okay, now one of the key things to remember when you're using categorical measures in regression is that you always leave one of the dummies out of the regression. Okay, I had mentioned that the way you decide which one to leave out is based on the frequency. So what we typically do is we omit the largest category from the regression and just include all of the other ones. And the coefficient that is generated for those other categories are being compared to the largest category. Okay, so in marital status, if we were to run frequencies of marital status, the largest category is married. There are more married people than anyone else. So when we stick marital status into our regression, we put in separated, divorced, widowed, never married, and we leave married out. Okay. The largest category in race is white, so we would leave that category out in our regression syntax. Okay. All right, this sums up the handout portion of the lecture. Go ahead and tune into the next video to begin the SPSS portion of linear regression. Thanks, guys.